Let's discuss non-parametric test for comparing two populations. It is a similar topic as chapter 8. Well, as we did before in chapter 8, we distinguish between independent sample and paired sample. Today we are going to discuss independent sample case. It is Wilcoxon rank sum test. Let's consider this example. There are two departments and we collect a sample of this amount from economics department, and we collect this student from management department. Well, we'd like plot histogram first to check whether the parametric test is good. Then we are going to discuss how to apply the Wilcoxon rank sum test. Why don't you generate data in this manner? It's in actually the ESTAT, the ESTAT EX icon. Well, they have example 10 to 1 in this manner. Here's some square data. These are the group data. If you click the square first and then group variable, they're gonna generate this output. And then you can switch to histogram. How do you think? Do you think you can apply parametric? Well, it doesn't look like the normal distribution. Therefore, you are not supposed to apply the t-test in chapter 8. How can you do that? These are the original data. These are the original data, and you arrange it in ascending order in this manner. But maybe each way would be, look at this. Well, I just arrange in ascending order, but I'd like to compare these two samples. After 57, next one is 65, the next one is 71, 75, and so on. In this manner, maybe you can arrange two sample data like this. Then you can easily assign their rank, starting from 1, 2, 3, 4, 5, 6, 7, but you have a tie here, 87. Therefore, you are supposed to give them rank 8 or 9. Take average of them, 8.5 each. Then 10 and 11, rank 10 and 11, there's also tie. Then you have to give this averaged rank. Then 12 and 13. What do you think? Why we are calculating this? I mean, if they follow normal distribution, then you can use the t-test in chapter 8. But histogram shows they do not like the normal distribution. Therefore, you calculate rank in this manner. Suppose two population median, the central location, one of the measure of central location, if they are equal, we expect the rank sum of these two would be equal, would be similar. If there is big difference, well, that's the sign. I mean, you can reject H0. Because of that, they consider all kind of possible rank. I mean, some statistician develop this kind of module to calculate all possible permutation of rank. And here are some of the ranks. Maybe you can select one of them. Here you select rank sum of the second population. Since the addition of a whole sample should be 1 plus n, that is n times n plus 1 divided by 2. Well, the R1 is just that number minus R2. You may use any one of them. We usually use this R2, rank sum of second population. Then we consider all kind of possibility and check the distribution of sum of rank. Okay. Then if you look at this kind of table, somewhere else x equal 28 until here is 0.017 is 0.025. If it is 5% significance level, somewhere else here would be critical value. We just take average of them. Or R2 is 56.5. And after this value, you have a 1.75%. This is 2.56%. Therefore, we take average of them like this. I mean, if you select in this manner the critical line, it doesn't match exactly your significance level. That's true for all kind of discrete distribution. In this problem, the calculated rank sum of second population was 36. Okay? We calculated in this manner 36. That means 36 would be located somewhere else here. Therefore, it has a good chance to accept H0. Actual calculation is if you enter data like this, sample 1, sample 2, and click execute button, they'll generate the critical line as this one. The test statistic is located here. Well, you would have output related with this test. And in general, using the rank sum of second population, we just compare with the distribution. If it is in the center, then we'll accept. In case of a right tail, we just consider this is the criteria for decision rule. This is left tail test. This is two-sided test. Let's practice using E-step. Click this button. Let's refresh this one. Click this button and click eBook. And then we are handling EX1021. As you see, data look like this. This is score data. This is department data. Click this icon and then click these two variables. Will generate the dot graph to compare mean. But you need to check whether they follow the normal distribution. It doesn't look like they follow normal distribution. In that case, you need to select non-parametric test. Clicking this one will generate out this. The first table shows you mean and standard deviation. At the same time, they show you some rank sum. Suppose D value is 0, that means we are testing M1 equal M2 or M1 not equal to M2. Test statistic is rank sum. It looks like this. And they calculate p-value. Okay. Well, you have a 0.31, that means you have to accept H0. Well, this is the Wilcoxon rank sum test, except we calculate rank of each data. Well, it is similar. But in case of a large sample case, you may use a normal approximation with the mean look like this, variance look like this. Using this normal sampling distribution, you can decide that if it is in the middle, then we will accept. If not, depending on alternative hypothesis, check right tail, left tail, or two tail. That's it for section 10.2. We'll discuss paired sample case in the next lecture.